So let's start with the Newton works. How did actually he literature review all the existing articles and books and journals in order to derive and formulate the calculus?
Newton didn't have modern literature reviews like we do today. He was in the thick of creating the new mathematics himself, but he built on centuries of ideas. He immersed himself in Greek geometry, Euclid, Archimedes, and studied contemporary algebraic methods. Key influences were works like those of Descartes and Viet, who advanced algebra and analytic geometry. Newton essentially absorbed all known mathematics of his time, both ancient and modern, and then pushed further. His development of calculus was a leap from those foundations, fusing the geometric and the algebraic into a new dynamic language of change.
So what you are suggesting about this centuries of ideas that he was reading?
I mean that Newton was standing on the shoulders of giants. He immersed himself in everything available, especially classical works like Euclid's geometry and Archimedes' methods. He also drew from more recent algebraic and analytical advances, think Descartes' geometry or Viet's symbolic algebra. In short, he didn't invent in isolation, he built from both ancient wisdom and his contemporaries' work, then made the leap into a new realm.
Okay, can you list out some of them so that I can better relate and understand how actually he was approaching?
Sure. A few key names to have in mind. Euclid's Elements gave Newton the geometric foundation. Archimedes' works showed how to approximate areas and volumes, early ideas akin to integration. Then you have René Descartes, who laid the groundwork for analytic geometry, linking algebra and geometry, and John Wallis, who worked on infinite series. Newton absorbed all these influences and blended them into his own revolutionary methods.
What was the fascinating point that you like most about how he approached the calculus?
For me, it's how Newton saw change everywhere in falling apples, in planets orbiting the sun, in curves on a page, and thought, I need a tool that captures this. His calculus was born from that obsession with motion and flux. What I love most is his ability to unify these ideas, turning geometry, algebra, and physical intuition into one powerful language of change.
What was that obsession?
I'd call it a relentless curiosity about the natural world. Newton wanted to decode every tiny shift, whether it was a planet's path or a changing curve. His obsession was seeing patterns in motion and distilling them into something universal. And that obsession gave us calculus.
Can you list out previous work from physicists like Galileo, Tycho Brahe, Kepler? How did Newton use their work?
Absolutely. Galileo gave Newton the principle of inertia, understanding that objects keep moving unless acted on. Tycho Brahe's precise astronomical data gave Kepler the fuel to derive his laws of planetary motion. Kepler's laws, especially that planets follow ellipses, were key for Newton. Newton took these ideas, how things move on Earth, how planets orbit, and unified them under his laws of motion and universal gravitation.
So, list out the contribution for the Newton that he made.
Newton's big contributions are massive. He formulated the laws of motion, laying the foundation for classical mechanics. He discovered universal gravitation, explaining how apples fall and planets orbit. In optics, he showed that white light splits into a spectrum of colors. And of course, he independently developed calculus, giving us a tool to handle rates of change and areas under curves. Each of these changed the course of science.
Oh, light splits into a spectrum of color. Can you explain that part?
Absolutely. Newton passed sunlight through a prism and saw it fan out into a rainbow: red, orange, yellow, green, blue, indigo, violet. He realized that white light isn't pure. It's a combination of all these colors. Each color bends a bit differently through the prism. In short, he showed that light is made of different wavelengths, and that laid the groundwork for modern optics.
What do you mean by modern optics? Can you give example to support this statement?
Modern optics builds on Newton's insight that light can be split into components. For example, spectroscopy uses that idea to analyze light from stars or chemicals, identifying elements by their spectral lines. Lasers are another example. They rely on controlling light's wavelength. Without Newton's foundational work showing light's complexity, we wouldn't have these precision tools today.
Okay, can you list out what we are discussing till now?
So far, we've been walking through Newton's intellectual journey. We began with how he built on centuries of past works, Euclid, Archimedes, Descartes, and others. We touched on Galileo, Kepler, Tycho Brahe, and how Newton unified their insights. We then listed Newton's contributions, his laws of motion, gravity, optics, and calculus. Finally, we explained how Newton's prism experiment opened the door to modern optics.